Okay. So first thing was if a molecule size increases, the melting boiling points are higher. Bigger molecules always have higher melting points when it comes to organic chemistry. And the other properties are that when you have a bigger molecule, a few other things also change when you have a bigger molecule. One thing is its bigger molecules are more viscous. Have higher viscosity. So have higher viscosity. इसका मतलब ये कि viscosity means कि viscosity is the thickness or the inability to flow. Viscous means that it's thick, does not flow easily. Just honey is thick, doesn't really flow very easily. So honey is very viscous. So bigger molecules have higher viscosity. They don't flow easily, just like candle wax. Or आपके पास अगर if you have petrol, तो उसको देखोगे that would be just like water. So as the thickness increases, the oil becomes thicker and thicker. The hydrocarbons, they become thicker and thicker. Bigger molecules are more viscous. फिर ये कि then you have another property, which is that bigger molecules are less flammable. They don't burn easily. Or less flammable. Very difficult to burn. Okay? So for example, candle wax is, the methane gas that you have in your heaters, that's a small molecule. It just has one carbon atom. Meth means one carbon atom. So it's smaller in size, and it burns very easily, catches fire immediately. But if you talk about a bigger molecule like candle wax, and that's a very, very big molecule. So you would realize that candle wax takes hours to burn. It burns very, very slowly. And it burns with difficulty as well. So smaller molecules, they're more flammable. So remember these three properties. Okay, one of them is that melting boiling points are higher for bigger molecules. Bigger molecules have higher viscosity, and bigger molecules also are less flammable as well. So bigger molecules are not very useful. Okay, they're not very useful because the number one use that you have for hydrocarbons is energy. Okay, that's the number one use that you have for hydrocarbons. So remember this point, that that bigger molecules tend to be less useful. Are less useful, and they don't tend to be a good source of energy. So if you have candle wax, you don't really use it for heating purposes, okay? क्योंकि उसने burn बहुत slowly करना है, so they're less useful, mainly because not a good source of energy. अच्छा, फिर इस पे एक चीज पढ़ लेते हैं कि where do you get all these organic molecules? Now, living organisms are, we're all organic. Okay, we are all organic. Every molecule in your body, that's probably an organic molecule made up of carbon atoms. And so what happens over billions of years? The trees, plants, animals, etc., their bones, they get crushed, and they get stored in the form of oil, fossil fuels. So fossil fuels are your number one source of hydrocarbons or organic compounds. So that's your number one source of hydrocarbons, organic molecules. And fossil fuels are normally obtained in the form of crude oil. Crude oil or petroleum. So what is crude oil? Crude oil is that black, thick liquid that is obtained. It's a black, and thing you must have seen this in movies, TK, when you're digging or drilling for oil, TK, you get this black, thick mixture of many organic molecules. अब इसमें ये कि it's a huge mixture of many organic molecules. Some of them are small, some of them are big molecules. So what you do is कि one thing that is done initially is that the mixture is separated. The different fractions are separated of crude oil by fractional distillation. So fractions or components in crude oil, you can remember that black substance is made up of many organic molecules. So the fractions are separated via fractional distillation. ठीक है, और fractional distillation काम किस तरह करती थी कि fractional distillation the molecules, why does fractional distillation work? Because different molecules have different boiling points. Some would evaporate easily, some would not evaporate easily. Different molecules have different boiling points. So this was the first chapter. If you remember, how does fractional distillation work? It works because different molecules have different boiling points. So here is what is done. Okay, crude oil separation is done in this way. Okay, the black thick substance liquid is taken into it's heated and vaporized. So there's this chamber over here at the bottom. You take crude oil, and the crude oil, the entire black substance, it's heated strongly, and it's always indirect heating. It's heated and it is turned into vapor. So it's heated and vaporized, and then the vapor, the hot vapor at very high temperatures, is passed into it's passed into this fractioning column, which is this one. इसको थोड़ा सा इस तरह कर लेते हैं. अच्छा, तो आप क्रूड ऑयल को हीट करो, वेपराइज करो, and the vapor is passed into this container. तो यहाँ पे आपके पास all these vapors of crude oil, and remember crude oil is a mixture of many different molecules. So ये hot vapor जो है ना, that starts to rise up. तो bottom के ऊपर ना there's very high temperatures. और जैसे जैसे आप टॉप पे पहुंचते हो ना, the vapor cools down and the temperatures are lower. So vapor rises and it cools down. So top के ऊपर you'll have lower temperatures. अच्छा ये सारा क्लियर है कि क्रूड ऑयल आपने निकाला है अर्थ से, उसको हीट किया है, वेपराइज किया है, हाई टेम्परेचर पे बॉईल किया है, और वो सारा वेपर जो बॉईल करके वेपर बना है वो इस चिमनी के थ्रू पास कर रहे हो। बॉटम के ऊपर द वेपर इज वेरी हॉट बिकॉज हाई टेम्परेचर यहाँ पे आप हीट कर रहे थे, एंड द वेपर स्टार्ट्स राइजिंग अप एंड इट स्टार्ट्स कूलिंग डाउन, इट स्टार्ट्स टू कूल डाउन। ठीक है, ये सारा क्लियर? सनीम इज दिस क्लियर? साद, नवाल इज दिस क्लियर? जैनब क्लियर है? हमजा क्लियर? मिनाहिल?
Yes, sir.
Yes, sir.
चलो, अब ये केस के अंदर ना ये जो there are many trays, perforated trays. Perforated का मतलब उसके अंदर there are lots of holes so vapor can pass through it. So the vapor would continue to rise, but there are trays that are placed in this column. What happens is right at the beginning, because शुरू में ही, there's a certain substance that has very high boiling point. वो vaporize ही नहीं होता, वो नीचे जाके ना बैठ जाता है, ठीक है, फौरन ही. And that substance is known as bitumen. So that's your residue. जब आप वेपराइज कर रहे थे ना तो सारी चीज इवेपोरेट नहीं कर रही थी, there were these big molecules, so really large molecules. ठीक है, remember bottom के ऊपर ना आपको क्या मिलेगा? You'll get large molecules. Why do you get them at the bottom? क्योंकि they're not going to vaporize. Why? Because they have very high boiling points. ठीक है, so बिल्कुल bottom के ऊपर ना what you're going to get is you're going to get these big molecules क्योंकि they're so big that their boiling points are so high कि आपकी जो strong heating है ना, even that is not able to vaporize them. तो क्रूड ऑयल को जब हीट कर रहे थे तो बाकी तो वेपर्स बन के they're rising up, but there's residue that's left, and that residue is known as bitumen. And this bitumen, so just hold on 1 minute, Azan. अच्छा चले, so remember कि the vapor is continuously rising, ऊपर जाके उसका टेम्परेचर ड्रॉप करता है, टेम्परेचर जैसे ही ड्रॉप होगा another substance would condense. जैसा steam का टेम्परेचर का ड्रॉप होता है तो it condenses back into water. तो but the bottom it's really high temperatures. तो जैसे जैसे वेपर ऊपर जा रहा है it starts condensing, it cools down. और वेपर के अंदर everything has a different I mean it's a mixture, it's got different molecules with different boiling points. So something else would condense. जैसे उसके boiling point से temperature कम होता है, it condenses, and you get petroleum jelly and waxes, which is I mean these things are used in car waxes, polishing stuff. फिर the vapor continues to rise, the leftover vapor continues to rise, और थोड़ा temperature drop होता है, something else condenses, and this time what condenses is in those trays, ठीक है, in those trays what condenses is fuel oil. So fuel oil or furnace oil condenses. Now this is used in large thermal power plants for producing energy at large scale. So thermal power plants, ठीक है, वहां पे it's used to produce electricity and mainly electricity. And the leftover vapor continues to rise. The temperature drops further and something else condenses in that vapor. And this something is now, I mean, these are your lubricating fractions. ठीक है, example machine oil, etc. I mean, for example, cars can you add engine oil. So all these fractions, I mean, these are known as lubricating fractions. Machine parts can आप add करते हो to reduce friction. I said then whatever is left, it continues to rise, and then you start getting diesel now. ठीक है, so the next thing that you obtain is diesel. The vapor rises again, whatever is left, and some molecules, they start condensing in it if the temperature drops further, and you start obtaining diesel. Now, where is diesel used? Diesel is used in your heavy transportation, notably trucks. Your big vehicles are all, they all operate on diesel. That's where they get energy. Then the leftover vapor keeps rising. The temperature drops further and something else condenses from it. And this something else is kerosene. Kerosene, also known as paraffin. That is used as airplane fuel. And in olden times, it was used, paraffin was actually used for lamps, etc. But you don't use that. So it's mainly, you don't use that anymore. The kerosene is mitti ka tel, that was frequently used previously. You use it in barbecues, etc. But that's not a big, large scale use. Mainly it's used as airplane fuel. Acha, baki jo vapor hai na, that keeps rising. At the end of the day, top ke upar, the vapor rises and you get, so the vapor is rising, the temperature drops further, and you get something else that condenses. Just as the temperature drop kiya ja raha hai, things continue to condense. And this time what you get is you get gasoline. That is your petrol that you add in your cars. So remember, the proper word is gasoline. Petrol is just short for petroleum. Petroleum is a mixture of all these substances combined. जो आपको crude oil, I mean, crude oil is known as petroleum. So remember, the correct word for the fuel that you add in your cars, that's gasoline. So America mein usko, they've shortened it to gas. So this is fuel for cars. अच्छा, फिर अभी कहानी खत्म नहीं हुई. There's there's one more tray that's on top of that. Okay, end के अंदर what you get is उन trays के अंदर ना you get naphtha. Now this is a raw material or a feedstock for the chemical industry, because remember I told you organic molecules. What are organic? I mean, humans, animals, plants, etc. We're all organic. So we need to make medicine. The medicine that you consume is also mostly organic. Okay? It's made up of carbon compounds. So if I mean, for example, if Panadol molecule structure, it probably looks like this. It's a bunch of, I mean, you don't see carbon over here. Just a second. So anyways, you can see carbon over here. There's CH3. So it's a bunch of carbon atoms, all even so it's, I mean, the black ones are all carbon atoms. So it's a bunch of carbon atoms connected to each other. So all your medicine that you consume, that's mostly organic molecules. Now there are two ways of obtaining these organic molecules. One is plants. That's most of your herbal medicine that is obtained from plants directly. लेकिन अगर आपने manufacture करना है at a large scale, at a very big scale, you need a lot of raw material that's made up of carbon compounds so that you can make this medicine. So naphtha is the raw stuff that you get over here. You make molecules and drug molecules out of that. Okay, medicine is made from that. So it's the feedstock for the chemical industry. And then there is something that does not condense at all. Okay, the temperature keeps dropping. Top ke upar na, you're at room temperature now. Okay, remember the temperature starts, the vapor kept rising, the temperature kept dropping. Bottom ke upar, you were heating the crude oil, so it was very high temperatures, and the top you have a very low temperature. So top ke upar aake na, you're at room temperature now. There would still be substances which there would be still some molecules left which are not going to condense क्योंकि उनका boiling point बहुत ही low होगा. So at the top, you're also going to get petroleum gases. Now, these are your gases that you get at your homes. I mean, petroleum gases, these are the gases. I mean, these are the gases that you use to, your geysers, your heaters, your cooking stoves, they all run on these. So petroleum gases are mostly used for domestic. They use for domestic heating. So the whole point is, I mean, the first thing is you have to remember the order of all these fractions, what you get from crude oil. Okay? So wo jo black substance, you got it from the Earth's crust. You drilled for it, you got the black substance. It's a mixture of many, many molecules. You heat it and vaporize it. It turns into vapor at very high temperatures. There would be certain substances that will not get vaporized. That's your residue that you get at the bottom of this thing. And that is known as bitumen. You make roads out of it. ठीक है, the black tar-like substance. ठीक है, वो अक्सर घरों में भी seepage खत्म करने के लिए you add that black substance. So that is bitumen. Then there's a lot of hot, high vapor at high temperatures. The vapor starts rising and starts cooling down. Now, there are many, many different fractions. So there are many, many different fractions. Different fractions mean different components, different molecules. Some molecules have high boiling point, some have low boiling point. The bottom ke upar na, high boiling point substances, they can start condensing. Because remember, high boiling point things, they condense early. So they start condensing. Sabse pehle petroleum jellies, the waxes, they start condensing. As the temperature, it keeps rising, the temperature keeps dropping. Just as the temperature drop hota rehta hai, some substance in the vapor, it starts to condense. So petroleum jellies and waxes, they condense. Then you get fuel oil and furnace oil. Then the temperature drops further. You get lubricating fractions. It drops further. You get diesel. You get kerosene. Drops further. You get gasoline, naphtha. So right at the top, the temperature is really low. So top ke upar aapko kya mil raha hai? Top ke upar the temperature is low. So what you get at the top is small molecules. Because remember, they have lower boiling points. Something that has lower boiling point, it's harder to condense. So smaller molecules are obtained at the top, and they've got lower and these ones have lower boiling points. तो ये याद रखना है कि what's the trend? The trend is कि top के ऊपर आपको छोटे molecules मिलेंगे, and at the bottom you're going to get bigger molecules right at the bottom, and gradually the temperature starts dropping when you go up. Higher boiling point things, they condense early. Lower boiling points things, they don't condense that early. Just कोई भी चीज lower boiling point है, that usually doesn't condense very easily. For example, अगर oxygen gas, it has a boiling point of -200, so it's very hard to condense it. Water has a boiling point of 100 degrees centigrade. It's very easy to condense it. So that's the whole thing, and you have to remember the uses of each one of them, and you have to remember the order of each of the fractions. So remember the order and remember the order and the uses and the names as well. एक और इसमें मैं add कर दूं कि what happens is कि large molecules are less flammable. So the things that you get at the bottom is mostly raw stuff, which is not very good. I mean, like, what do you do with waxes? I mean, there's not a lot of uses for waxes. The number one use of obtaining crude oil is energy. So right at the bottom, molecules are not very flammable. This is something that we discussed. Big molecules are not flammable. So not very flammable molecules at the bottom. और जैसे जैसे आप टॉप पे जाते रहोगे, the smaller molecules are more flammable. तो ये आपको ना पूरा याद रखना है, मेमोराइज करना है everything, और इससे ज्यादा कुछ याद करना. So is this clear? ये clear है?
Yes, sir.
अच्छा, अब ये कि ये तो आ गया कि where do you obtain your most of the organic stuff that you use every day. Plants, animals वगैरह के अलावा, the other place that you obtain this stuff is crude oil. And separation is done because they have, I mean, the mixture has different boiling points. अब ये कि there's one problem over here, and that is कि bottom वाले ना useless है. But you get a lot of bitumen from it. ठीक है, वो जो black substance जमीन से मिला ना, it's got a lot of tar in it. Now, tar, first thing, is an extremely cheap substance, and there's not much use for it. You make roads out of it, but remember, like around Islamabad, there are lots of refineries that are constantly producing this black tar-like substance, and they have no use for it. I mean, you're not making enough roads. जितना आप crude oil निकाल रहे हो. So this thing is, at the end of the day, it's kind of useless. Petroleum jellies or waxes वगैरह, they're also kind of useless. You don't need that much of it. So the thing is, most of this stuff is probably going to waste. So what is needed is, there's another process that happens. ये जो ऊपर वाला stuff है ना, that is very useful. कि आपके घरों में energy is produced, petroleum gases, domestic heating. Naphtha, you make medicines out of it. Remember, medicine molecules are most of the time like kind of really small molecules. They're not big molecules. They just have 20, 30 carbon atoms, that's it. Gasoline, okay, that's a small molecule, burns very easily. Kerosene burns very easily, so all your airplanes are running on it. So there's a division that you're getting a lot of wasteful things, and you're getting small molecules not in the right quantity. You need more of them. So there's another process that is done, and that is the cracking of long chain hydrocarbons. अच्छा, cracking के अंदर what is done is an additional reaction is done कि जो फालतू का जितना भी big molecules, ठीक है, the large molecules are not very useful. But and they have a number of problems that they're not flammable. They don't flow easily. मतलब waxes, ठीक है, you can't I mean wax will not pass through a pipe. जैसे आपकी domestic gases जो होती हैं, they can flow through pipes. Waxes will just get stuck. So they're not viscous or semi-solid type होती है, ठीक है. So large molecules are not flammable. That's the number one reason why they use this. Not very useful. अभी ये क्या, what do you do? These molecules are taken and they're literally broken down into smaller pieces. So they are broken down or cracked into smaller molecules at high temperatures with catalyst. So this process is known as cracking, that the big molecules are broken down, literally cracked to give you smaller, more useful molecules. So for example, अगर यहाँ पे candle wax, 1 second, molecule. As a candle wax molecule size. So you can see it's a molecule that's between 20 and 40 carbon. That's paraffin wax, ठीक है. So it's around 40 carbon atoms. Bitumen का कर लेते हैं size के क्या है. नहीं, ये कुछ और ही आ गया. Just a second. Bitumen. So I'll just take this. Okay, let's say I have candle wax. And let's say it's a molecule that has around 40 carbon atoms, and let's say there are 82 hydrogen atoms. So that's a big molecule, not very useful. So what you do is you take this molecule, and at very high temperatures, the molecules are going to bump into each other with a lot of force. Okay, so the molecules are taken at very high temperatures, and at very high temperatures, the collisions are going to be very vigorous. So ये इसके साथ collide कर रहा है, they're all colliding with each other with a lot of force. And there's a catalyst involved as well. And what happens is the molecules, they start breaking down into smaller pieces. Okay, you get lots of tiny molecules. For example, you might get C10H22, you might get C5H12. So all these tiny molecules are obtained when the big molecules, they start breaking up into tinier and tinier pieces. You might get C2H4, you might get hydrogen gas is also sometimes obtained because the hydrogens, they get cracked as well. So you get a mixture of alkanes. Alkanes, remember, has a general formula of CnH2n plus 2, which we just did yesterday. And you get a mixture of alkenes as well, CnH2n as well. And you get lots of them. You get lots and lots of these tiny molecules are obtained. So इनको सारों को सर्कल करते रहते हैं और बहुत ज्यादा होंगे, ठीक है. This would be a lot in quantity. So क्योंकि remember, these huge big molecules are breaking down into tinier and tinier pieces or smaller pieces. So you get lots and lots of these really small molecules. So let's say ये और आ गया आपके पास. So the point hopefully is clear. Okay, these big molecules over here that you're obtaining from crude oil are not very useful, and these molecules are literally cracked or broken down into pieces at very high temperatures in the presence of a catalyst as well. The catalyst most of the time is Al2O3, which I'm going to write over here. Or SiO2 is the catalyst that's used. It's sometimes known as pumice. It's a rock. It's a type of rock that has these two things: pumice or zeolites. Okay, that's the name of the rock that has these two Al2O3 SiO2 mixture. Okay, it's got both of them, and that's used as a catalyst for this. The big molecules are literally cracked to give you these smaller, tinier molecules, and these smaller molecules are more useful. Why? Because they're more flammable, and they've got lower boiling points as well, so they flow easily. So they're more useful and more flammable. And less viscous, which means that they flow very easily through pipes, etc. So you can transport them very easily. So वो वाला मसला भी नहीं होगा इसमें. So all the waxes that you take, all the bitumen that you have extra that you've produced from crude oil, it's broken down into smaller pieces. ये सारा clear है सारों को? Hamza clear, Nawal, Saneem, is this clear? Zainab, is this clear? तो ठीक है, बस ये चीज पूरी मेमोराइज करनी है. Fractional distillation of crude oil, and plus in addition to that, these bigger molecules not very useful, so they are cracked to give you these smaller molecules, which are a mixture of alkanes, alkenes.
Yeah.
Hanji.
Alkanes are cracked, right?
Which one? It could be
Alkanes.
it could be any big molecule.
Okay.
Okay. Any big molecule might have 100 carbon atoms or like 200 hydrogen atoms. It could be any big molecule. That is simply broken down and you get a mixture of small alkanes, alkenes, and hydrogen gas. वो मैं यहाँ पे लिख भी देता हूँ. ठीक है, so you get smaller alkanes. और वो random होता है process. I mean, you could get any alkane. This was the general formula: alkenes. And one more, that's hydrogen gas as well. Okay. So so let's continue tomorrow. तो अभी मैं सिर्फ हमजा के questions answer कर लूं. कोई question नहीं है किसी का? जी फिर हम कल continue करते हैं, ठीक है? So okay everyone. Take care, Allah Hafiz. अच्छा, Hamza, are you there?
Yes, sir.
अच्छा, मैं questions खोल लूं एक second.
And sir, will there be any past paper class?
कल try करते हैं, ठीक है?
Okay.
अच्छा, इसमें तो ये मैंने खोल लिए, just a second.